All you guys are preparing well. And in the last session, we discussed about the basic introduction part on the mixtures topic. And also, I told you that knowing the topic of ratios and proportions will help in solving the problems of mixtures in an easy manner. The introduction part related to the mixtures that we already covered in the previous sessions in a detailed manner. And in this session, we try to focus on the problems which were asked in the previous and recent examinations here. And these problems will give you an idea of how to solve or how to tackle the questions in an easy manner without wasting much time in the particular questions. Let's see some questions and which were asked in the previous session here. And here is the first question. And here is the first question. What is this question means? There are two vessels like A and B are the two alloys of gold and copper. So there are two alloys here present. So this is alloy A and this is alloy B here, and it contains gold and copper, and it also contains gold and copper, and these are prepared by mixing the metals in the ratio of 5 is to 3 and 5 is to 11. So it is in the ratio of 5 is to 3 and it is in the ratio of 5 is to 11. Next, what I gave, equal quantities of these alloys are melted to form a third alloy. So there is a new alloy, that is alloy C, and it is also contains gold and copper. That ratio we need to find here. What is said, he is taking equal quantities of these alloys here, which means he is taking or he is mixing them these two alloys A and B, and it is in the equal ratio, equal quantity. Equal quantity is nothing but he is taking one part from alloy A and taking one part from alloy B. So he is mixing it in equal quantity or equal ratio. Then what he asked in the question is the ratio of gold and copper in the new alloy. So this is you need to find here. So first we'll try to explain this one by using with the general method. After the completioning of general method and how to approach in a shortcut method, we'll try to see here. So first we'll try to take the gold quantity separately and copper quantity separately. So first, in order to find that one, first we need to know how many parts are present individually in alloy A and alloy B. So the number of parts present here is 8 and the number of parts present here is 16. Sir, how you got the number of parts as 8 and 16? Just you need to simply add these values here. 5 plus 3 will give us 8 here and 5 plus 11 will give us 16 here. Next, in the alloy A, what is the number of parts of gold out of 8 parts? So gold is of 5 parts out of 8 parts. And in the alloy B, now we are adding these two quantities here in order to form a third alloy. That's why I am taking the plus symbol here. And after that, what happened here? The gold quantity is also 5 parts out of 16 parts here. So this is related to gold quantity, and similarly we are also considering the copper quantity. So the copper is of 3 parts out of 8 parts and plus, and the copper is of 11 parts out of 16 parts. Now if we take the LCM as 16, LCM as 16 on both sides, so it will be like a 10 plus 5 and it will be like 6 plus 11, and this 16 and 16 get cancelled, it will like a 15 ratio 17, 15 ratio 17. So this is the quantity of gold and copper present in the new vessel C, so which is presented in option C. So this is if we go with the actually saying in the last session we discussed that a formula approach, like formula approach is like what, a1 plus a2 divided by, so this formula we already discussed here, a1 divided by a1 plus a2, like b a2 divided by a1 plus a1 plus a2 and divided by b1 divided by a1 plus b1. So here it is b1 and here it is b2, and b2 divided by A2 plus B2. This is the formula we discussed. The same formula we are representing in this manner without remember. Why? Because remembering the formula is difficult all in a difficult for all the cases. That's why we are not discussing the formula here. Without discussing the formula, we are representing the values here by taking the total quantity or the total portion present here. Now let us try to see without solving this one with this method. But let us try to solve this one here in a general manner, or how to solve this one is in a shortcut manner. We try to see here. Let us try to see how to solve this one, this portion in a shortcut manner. We try to see here. Let us try to solve this one here. Let me clear off the things present here. Okay. Let us try to solve here. So what is the gold and copper quantity present here? It is presented in 5 is to 3 ratio, and in the alloy 2 it is in 5 is to 11 ratio. So what you need to do, you need to take the number of parts here. The number of parts here it is 8 and the number of parts here is 16 here. So when solving with the shortcut method here, when solving with the shortcut method, what you need to remember is you need to make the number of parts to be same before mixing them. You need to make the number of parts present in both the containers or both the alloys or both the vessels must be same here. So in order to make so here the L value is 16 here. So in order to make this one as 16, so you need to multiply this one with here 2 here. So if you are multiplying this one with 2 here, here also you need to multiply this one with 2 here. And after what he gave, he asked us to mix it in equal quantity. Equal quantity means 1 is to 1 ratio. So you need to mix it in equal ratio. After mixing them between equal ratio, it will be like 10 ratio 6, and it will be like 5 ratio 11. After adding the values here, it will be like 15 ratio 17 here. See here with this approach, how much time you are taking to get the answer. The only point you need to remember is before mixing the quantities, you need to make the number of parts to be same here. So with this method, you can get the answers in an easy manner. All you need to make the number of parts to be same before mixing the quantities. After that, you can mix it in equal ratio or any of the defined quantity ratio. I hope you are clear with this explanation. And let us move to the next question here. And here is the next question. Here is also the same thing happen here. What he gave? There is a mixture A. There is a mixture A. Mixture A contains chocolate and milk in the ratio of 4 is to 3, and there is a mixture B, and it contains a chocolate and milk in the ratio of 5 is to 2. This A and B are taken in the ratio of 5 is to 6. By what it means, from A it has taken 5 parts, and from B 6 parts are taken, and mixture to form a new mixture. So let us assume a new type C mixture was formed. So in this one also it contains a chocolate and milk in some defined ratio. And what he asked in the question is the percentage of chocolate in the new mixture closest to. So we need to find the percentage of chocolate ratio we need to find here. So this was the question you need to find here. So directly going the shortcut method, and if you want to solve by using the traditional method, you can also solve. You can also get the same answer here. So here I'm taking chocolate and milk quantity. Here it is a 4 is to 3 ratio, and here it is a 5 is to 2 ratio. So what I am told before mixing the quantities, what you need to do is you need to make the number of parts to be same in both the containers here. So here the number of parts here is 7, and here the number of parts here is 7. So when the number of parts are 7, there is nothing to do. And all you need is here the number of parts are same or maintained same here. After maintaining the number of parts same here, what you need to say, you need to mix them in the ratio of 5 is to 6. So what it means, we need to take 5 parts from container 1 or mixture A, and we need to take 6 parts from container 2 or mixture B. So after multiplying the values, we also get the chocolate to milk ratio as 5 4 is of 20, and 5 3 is of 15, and 6 5 is of 30, and 6 2 is of 12. And if we add the things here in order to mix it in a big container, it will be like 50 ratio 27. 50 ratio 27. And what he asked in the question, so how many parts are present here? So there are the number of parts present here will be 87. The number of parts present, okay, not 87. The number of parts present here will be 77. And what he asked in the question, what is the percentage of chocolate in the new mixture closest to? So we need to find the percentage of chocolate. So what is the number of parts in chocolate in the new mixture? So it will be 50 parts out of 77 parts. We need to find the mixture that is 100 percentage. So what you'll get? So you'll get the ratio as so what you'll get 50 divided by 77, and so if we multiply the values of 50 with the 7, suppose this value, let us consider this one as a 75 here. So if we take the 7, why? Because I am approximately calculate the values here. So it will be 25 twos and 25 threes get cancelled. So 2 by 3 is nothing but say 2 by 3 is nothing but 66, so 2 by 3 here. So the value which is nearer to 66 here. Why? Because here I am considering 75 instead of 77. So my value is very slightly lesser. So my value will be closest to 65%. Likewise, you can also solve this question here. I hope you are clear with this explanation, and let us move to the next question here. And here is the next question. There are two alloys made up of copper and aluminum. There are two alloys made up of copper and aluminum. In the first alloy, okay, let us see the explanation here. So it is a first alloy, alloy 1, and it contains copper and aluminum. So what he gave the first alloy, in the first alloy, copper is of as much as aluminum. Suppose if the aluminum is 1 part, copper is of half part. And if we convert in the ratio here, it will be like 1:2 ratio. And in the second alloy, copper to aluminum, like in the second alloy, copper is thrice as much as aluminum. Suppose if the aluminum is 1 part, the copper will be of 3 parts. And what he asked in the question, how many times the second alloy must be mixed with the first alloy to get the new alloy? Suppose these two are mixed, and here we need to find the ratio. Let us assume the ratio is of x ratio y. And in the new mixture, and in the third mixture, copper to aluminum ratio, what he gave, copper is twice as much as aluminum. Suppose if the aluminum is 1 part, copper will be of 2 parts. So this is the ratio. What he asked means we need to find this value. If we find this value, we will get the answer here. So let us go solve. Okay, let us try to solve this one with the normal approach here. So here the copper and aluminum, it will be 1:2, and it will be 3:1. And here the number of parts here will be 3, and here the number of parts will be 4. So as I said that we need to make the number of parts to be same before mixing them in an equal ratio or in some defined ratio. So this I will multiply with 4, and this I will multiply with 4. And in what ratio I have taken, or what is the quantity I have taken from container 1, and what is the quantity taken from container 2, I didn't know. So this I will multiply with x here, and this I will multiply with y here. And if I do the things here, it will be like a 4x and 8x, and it will be like 9y and 3y. And at the end, we'll get the new mixture ratio must be 2:1. And we need to add these values. After adding the values here, it will be like 4x plus 9y divided by 8x plus 3y, that will be equals to 2 by 1. If I cross multiply the things here, it will be like 4x plus 9y, that will be equals to 16x plus 6y. And if I rearrange the values here, it will be like 3y will be equals to 12x. 3 ones and 3 fours get cancelled. Y will be equals to 4x. So what he asked in the question, how many times the second alloy? The second alloy here value we are taking as y, and the first alloy value here is by 4 or x we are taking. So how many times we need to take here? So the second alloy must be mixed with the 4 times of the first alloy. So the answer for this particular problem will be option C. 4 will be the answer. So this is the easiest way to get the answer for this particular problem. And let us move to the next question. Okay, let us consider this as an homework problem for you. Let us try to solve and comment in the comment section, and we'll try to discuss the same problem in the next session. If you got the answers for this particular problem, let us try to comment your answers in the comment section. Have a good day. We'll meet in the next session with one more interesting topic. Thank you for watching the session.